Geometry section 3.2, the converses. Basically, we're going to go through 5 converses of the theorems that you learned in 3.1. Not every theorem has a converse that's true, but the 5 theorems that were covered in section 3.1, they all have converses that are true and are important to us in geometry early on here in chapter 3. So you should have already received this document. It's about a third of a sheet of paper. I think I would have handed this to you probably the day before you watch this video, or maybe the day of. And you'll notice that there are a few basic things on here that are from the previous chapter or chapters: vertical angles and definition of supplementary transitive property substitution. These are the abbreviations you should use. And again, I've explained in class and in a previous video that the list here is going to grow throughout chapter 3 and chapter 4. The list of theorems, definitions, postulates, properties, and then their abbreviations. This list is going to grow as we establish more things in chapters 3 and 4. You will always get to use this on quizzes and tests where it applies, okay, and also the exam in December. So besides the 4 things that I just mentioned, here are the 5 abbreviations that we talked about in section 3.1, and now I'm telling you that the converse of all 5 of these theorems is also true. Now think about it this way, and let me try to give you an explanation as to why we do things the way we do them. Would you prefer in a proof that when you have to cite the corresponding angles postulate to have to write this, corresponding angles postulate? And then, let's say you had to use the converse, you'd have to write the converse of the corresponding angles postulate, or maybe you could even abbreviate that to corresponding angles converse, but that's still long. We like these abbreviations. I very much like these abbreviations, and in fact, I require you to use them exactly as they are. Your first quiz is coming up that'll cover 3.1 and 3.2. You need to use these abbreviations when you're writing a proof, okay, not the name. Because bottom line is there are actually 2 corresponding angles postulates and 2 alternate interior angles theorems, right? There's the theorem and then there's the converse. So if you just said corresponding angles, I wouldn't know which one you're using. This abbreviation establishes order. Parallel lines implies corresponding angles are congruent. This is the converse of that. Corresponding angles are congruent implies that lines are parallel. Okay, so again, this is something that you get to use throughout chapters 3 and 4. You do not have to memorize anything on this piece of paper. You should use these abbreviations as we give them to you exactly, because you will have this sheet to copy off of when you are taking quizzes and tests in chapters 3 and 4. Okay, so think about this now. In my classroom, I have blinds over by the window. You probably have blinds in your house. If you looked kind of down the side of them, kind of, I don't know how to say it, but if you got up next to them and you looked, long way, so you're kind of looking through them, not directly at the window, but kind of with your head next to the wall, looking down. I don't know how to describe this, but you would see something like this, right? If the blinds are open, and these verticals are to kind of represent the strings that are on my blinds here at school, and then these horizontals would be the blinds themselves. Okay. Now here's what is true. What's true about this is that these angles are congruent, and maybe they're right angles. I kind of drew them that they would be perpendicular, but you wouldn't have to know that. The point is that they're all congruent. Okay. Now here's the thing. What if I turned the knob on my blinds? And just to keep it simple, let's just say that they closed like, not like that. I want to use blue. And let's say they close somewhat, and they do this. Now again, this is imperfect, but you gotta go with my picture here. Wouldn't it still be the case that, where the black ones were parallel, wouldn't the blue ones now be parallel? And wouldn't it be the case that this angle is congruent to this angle is congruent to this angle? Okay, so this is somewhat a model for corresponding angles being congruent implies that lines are parallel. Again, in the previous lesson, we showed that if the lines are parallel, then the corresponding angles are congruent. The converse to that is also true. If the corresponding angles are congruent, then we can imply that the lines are parallel. Corresponding angles congruent implies that lines are parallel. Okay, just the same, alternate interior angles congruent would imply that lines are parallel. So for example, let's use a different color. This angle and this angle would imply that this is parallel to this. This angle being congruent to this angle would imply that this is parallel to this. And we'll get more into that in an example here in just a few moments. Okay? So actually, let's do that now. Let's go to some examples. We'll come back and finish with the proof. This says, use the diagram which lines, if any, must be parallel if angle 3 and angle 2 are supplementary. So look on the diagram and identify for yourself where angle 3 and angle 2 are. Okay? I'm marking them different because they're not congruent. In fact, they tell us that they're supplementary. So 1 arc mark on this one, 2 arc marks on this one shows that they are probably a different measure. And can you classify those? If you can't classify these, I would implore you to go back, to pause this video, go back and rewatch 3.1. You got to know those words, those 5 terms: corresponding angles, alternate interior angles, alternate exterior angles, same side interior, and same side exterior. These would be same side exterior. Here are the potentially parallel lines. This would be the transversal, and angle 3 and angle 2 are exterior, those 2 parallel lines. They're on the same side of the transversal. They are same side exterior angles. And what do we know? We look at the question. Which lines would be parallel if we know that angle 3 and angle 2 are supplementary? So that would be line EC and line DK would be parallel. Okay, now this is the old labeling, naming system for lines. We will more often be calling them by lowercase letters now, just single lowercase letters. But this is all they gave us for this diagram. So you got to use the old chapter 1 style, doing it with the line symbol over the top. Okay. It is the case that this line and this line are parallel if these 2 angles are supplementary. Okay. Here's one that has nothing to do with proofs. Oh, by the way, this really didn't need a justification, but just so you know, same side exterior angles that have a sum of 180 implies parallel lines. This is what I use to show this, what I use to justify this. All right, now this next diagram has nothing to do with proofs. It's just really a solved situation. We all have to agree that this angle is congruent to this angle by alternate interior angles. That is to say that parallel lines implies alternate interior angles are congruent. They're actually asking the opposite question here. I'm not crazy about the wording of this, but this is the problem they give me. Find the value of x for which L is parallel to M. Basically what they're saying is you figure out what x is, and then such that the angles would be congruent, because then we could conclude that the lines are parallel. It's not a well-worded question, but nonetheless, it's an algebra problem. So we would go 14 plus 3x is equal to 5x minus 66. And we could solve that real quick. We'll subtract 3x from both sides, add 66, and divide by 2. X would be equal to 40. Okay. Now again, no proof work to be done on that problem. We're going to do a proof in just a second though. Okay, last one, and this is an important one. I think it's kind of the setup is kind of dumb when they say it's a wooden frame, when it really doesn't look like a wooden frame. But the concept here is so important. You got to get this. If you understand this, the rest of chapter 3 just got a little bit easier for you. It says a rectangular wooden frame has a diagonal metal brace. The angles indicated were measured to be equal, as in congruent angles. And it says which sides are parallel. Now again, pause the video like I sometimes suggest and see if you can decide which sides would be parallel, because I'm about to say. And the sides that would be parallel would be these 2. Okay? And again, you got to get this. This angle is formed by this transversal and this side. This angle is formed by the same transversal and this side. These are the lines that would be parallel because alternate interior angles congruent implies that lines are parallel. Okay? It is not the case that this one would be parallel to this one. That is not the case. Notice that there's nothing to do with this angle that is helped to be formed by this side, and this angle here, which is formed in part by this side. Okay? So that's not true. This is not true. This side is parallel to this side because the angle has to do with partially that side. It's formed by these 2 segments, if you will. This angle is formed by these two segments. All right, so then let's end this with a proof. Let's go ahead and prove. I could have picked any of the four, right? The first one's a postulate again, but any of the other four, I just decided that this time we'll prove the alternate exterior angles converse. The abbreviation of such is this right here. Oh, not interior, exterior. Typo. Alternate exterior angles converse. Okay. Now, right away, let me shorten something up for you. You no longer have to write statements and reasons. You can just put SR. Okay. You can do this from now on your proofs. What do we do with the proof? Well, we write number one. We write what's given. Angle 1 is congruent to angle 7. We justify that with the word given. Okay. We're also going to go ahead and mark that true on the diagram. Now, I have said in previous video and also in class that you cannot use the theorem that you're trying to prove the theorem, right? So we're trying to prove this theorem. We can't use the alternate exterior angles converse in the proof of this. It's got to be something. The things that we use have to have come to us prior to the moment that we actually were given this, which I just gave it to you in this video, right? So what is at our disposal? Well, the ones prior to it are the alternate interior angles converse. AIA congruent implies parallel lines. Prior to that, we had corresponding angles congruent implies parallel lines. And prior to that, we have all the stuff from chapter 1 and chapter 2. Okay, and that'll be enough to do this. So what do you notice? Look at the picture and what do you notice? Well, I would notice, for example, that angle 3 is congruent to angle 1. That would be the vertical angles theorem. This is an abbreviation that is on your sheet. Angle 3 is congruent to angle 1. Okay? Then I would say angle 3 is congruent to angle 7. Now, critical. There's a couple critical points in this lesson, and here's the other one. This is not corresponding angles. You want to look at this and go, oh, 3 and 7, they're corresponding angles, and you want to put something about corresponding angles here. Wrong. We don't know the lines are parallel. You do not know these angles are congruent because the lines are parallel. Okay? We're actually trying to prove the lines parallel. We don't know they're parallel. So this is not corresponding angles. Look into your previous lines of the proof and you'll find your justification for this. If one's congruent to 7 and one's congruent to 3, then 3 and 7 are congruent. This is the transitive property or substitution. And since this is of congruence, these are all congruent symbols. This is the transitive property of congruence. Okay, now let me say that again. This is not corresponding angles. Yes, I know that 3 and 7 are corresponding angles, but this theorem does not apply because the one you're thinking of says parallel lines implies corresponding angles are congruent. When we say these angles are congruent, that doesn't work here. What does work is the transitive property because of what we wrote above. Okay, but now that we know that 3 and 7 are congruent because we stated it in our proof, now we can say that the lines are parallel. Line L is parallel to line M. Why? Well, again, I'm trying to go slow and be really deliberate here. We're concluding that lines are parallel, so it must be one of these 5, right? We just said, hey, the lines are parallel, so it has to be something implies that lines are parallel. Which one is it? Well, it's corresponding angles. Corresponding angles because 3 and 7 are corresponding angles. Again, I couldn't use parallel lines implies corresponding angles are, parallel lines implies corresponding angles are congruent. I couldn't use that earlier because I didn't know parallel lines. Now I can use its converse though, corresponding angles congruent implies parallel lines because 3 and 7 are corresponding angles and we just showed they're congruent. Corresponding angles congruent implies that lines are parallel. And that's done. You wanted to prove L is parallel to M. You did that. You justified it. It was a 4-line proof. That's done. All right. Thanks for tuning in.